We are doing autonomous differential equations part 2. So from part 1, it's very important to identify the autonomous differential equation, to identify whether or not it's autonomous. Secondly, it's important that for autonomous, we find the solution using a sketch, and we actually find the solution without solving the differential equation. And then the last part, very important, we will find the constant or equilibrium solution, and we will check where the function is increasing or decreasing. So in the previous video, part 1 for autonomous, I gave you these 3 examples to do. We will focus on number 1 and number 3. So for number 1, we see immediately it's autonomous since the independent variable does not appear explicitly in our equation, hence autonomous. Our first step is to check or to find the equilibrium or constant solution. Constant solution is always where our derivative is 0. So in other words, where our function y minus 2 to the 4 is 0. And from school, you know that we can fourth root both sides. So y is 2. That is our equilibrium solution. So important now, when we do our equilibrium solution, we will sketch through y equals 2. So 2 is here, y equals 2 will be our straight line, and that is our equilibrium solution. And just a reminder, your sketch can never go through the equilibrium solutions. Now, to see where my function is increasing, I will do where the derivative is greater than 0. So in other words, where my y minus 2 to the 4 is greater than 0. Now, a common mistake students make when they do the inequality, they take the fourth root on both sides and they just get y is greater than 2. Why is that wrong? Since this is an even exponent, no matter what value, x value, you're going to substitute in, you're always going to end up getting a positive y. Because from school, I don't know if you remember, but when we have an even exponent, our graph will look like that, and our function is above the horizontal axis. So increasing for all real numbers except 2. Why except 2? Because remember, when we substitute 2 in, we will get 0, but we want greater than 0. So it is true for all real values. Therefore, decreasing the opposite, but since our function is increasing for all real values, we see there is no solution for y for decreasing. This is not positive. So our function is going to increase all the way, but remember now it cannot go through the equilibrium. So it is increasing in that direction, and here it will be increasing in this direction. So if they give you that y of 0 is y0, remember it will be there, and your graph will go through y0. And there we have done the sketch for our first problem. Our second problem, slightly harder. So first we identify why is it autonomous? Because the independent variable not explicitly in our fy. Now we're going to find the solutions by a sketch without solving the equation. So, first step, we're going to do our constant solutions. Constant solution is when the derivative is 0. Now, a common mistake students make here, they forget when you have two brackets to make each bracket equal to 0, like I did here. You need to make each bracket equal to 0. The mistake students make, they try to times or distribute in, which is impossible. You cannot do this. So I make each bracket equal to 0. I get y is 0, or ln y plus 2 is 0, which means y plus 2e to the 0. E to the 0 is 1. And I get y is negative 1. So my equilibrium constant solutions will be y equals 0, y equals negative 1. So please make 100% sure you understand this. There's my green, y equals 0, which is the x-axis. And then I have y equals negative 1, my equilibrium. Now what I said, it is very important to do the domain as well. So common pitfall there also. So just make sure here your domain for y for this bracket can be all real numbers. But when I have ln, you know from first year, whenever we have ln, your bracket must be greater than 0. So what students do wrong, they will say greater than equal to 0, which is wrong. Remember, you cannot get ln of 0. So my domain will be y greater than negative 2. What does that mean? Anything below and equal to negative 2 is out of bounds. I will not be able to sketch here. So let's check where f of y is increasing. So I have my derivative greater than 0. Now this is quite a tricky one. Remember this sketch for ln y plus 2. Your ln graph will move 2 units to the right. So, to the left because it is plus 2. And remember, my critical value was negative 1. And remember, I cannot sketch here. There goes my graph. Why did I sketch it? Very important. Here, I know that my critical value is 0. Here, I know that my critical point is negative 1 for this part. But now, very important, so I do plot my negative 1 and my 0. But let's check. So this is a common mistake from students. Remember now, you have y, ln y plus 2 greater than 0. Let's see if we use a number greater than 0. Let's use 1. If I substitute 1 in here, I get positive. If I substitute 1 in here, so I see I also get a positive. Positive times a positive greater than 0. Let's do a value between minus 1 and 0. I don't even have to a specific value. I know that this now is a negative since I'm doing between minus 1 and 0. I know now less than 0 between negative 1. Yeah, but what do I see? I still have a positive there. So I have a negative times a positive, which is a negative. So this is a mistake students make. Let's just recap that quickly. This part, I'm checking between -1 and 0. What do you see my y values are? Positive. My y is here, negative. Now I'm doing on this side less than -1, but remember I'm going greater than -2. So if I do values in between here, what do I see about my line graph? My y values are negative. So here I will have a negative. Here I have a negative. Negative times negative, positive. So that was a bit different. Now remember, for increasing, we're looking at the positives. Where do I have a positive? I have a positive greater than 0 and not equal to greater than 0, and I have a positive between -2 and -1, and then decreasing the negative, so I have between -1 and 0. So let's sketch this one quickly. So as you can see here, the pink for increasing, I've done the pink for increasing. So from -2 to -1, there goes my line. Why did I not draw below -2? It's not in the domain. And then if I have y of 0 is x0, I will go through that initial point. Then also increasing greater than 0. Hence, this graph increasing. Decreasing, let's do the purple for decreasing. Decreasing between -1 and 0. Hence, my decreasing in that direction. So the direction is also very important. Now what they like to ask in tests, they will say, what is the limit as x approaches infinity if y of 0 is -3/2? Now you know 0, -3/2, it will be around about here, because here we have -2, -1, -3/2 between there. But now as x approaches infinity in that region, what will my graph approach? It will approach -1. So this answer, and like I said, it often comes up in tests, this will be -1, but only if I'm given this. If I'm given something else, say I'm given, I know this was 0, say I'm given now y of 0 is 7. Now what will my limit be as x approaches infinity? So say that was 7. Don't say the limit 7, infinity. This graph is going to continue indefinitely. So yeah, my answer will be infinity. And those are the two examples I have done here, which it's very important to make sure you understand this before a test. And this is the end of Autonomous Part 2.